Okay, this is my code for Lab 8. The objective of this lab is to successfully map the unknown environment and position robot at the center of the unknown area using wheel encoder and ultrasonic sensor. Once the robot reaches the center of the area, it should signify a constant red LED to signal that the program has ended. So here we include the ROMI library. Here are the classes: encoder, motors, and button A. In this section, it lists all the defined constants or magic values. Here it lists the variables. In this case, count left variables to store the left encoder count. Count right variables to store the right encoder count. Number of pulse variable is to store the number of pulses needed to travel a distance. This is when this is driving straight. Num pulse variables to store the number of pulse needed to turn in place. The distance array variable declared to store the measured distance. In our setup, we declare the trig pin as an output, echo pin as an input. Before starting the program, wait for the user to press button A to start the program. Following that function, a 2-second delay will be called to give the user 2 seconds to prepare for the program. And in our for loop, we will measure the distance initially. That will be stored in dist. Once we collect that information, the robot will turn clockwise 8 degrees. Once the robot is repositioned, it will gather another distance, store into dist 2, and then we'll use the if statement to determine the closest distance. If the information in dist is greater than dist 2, the robot will continue to turn clockwise 8 degrees to find the closest distance. Else, if let's say if the information dist 1 dist is less than dist 2, it'll go to else statement. The robot will turn clockwise to its previous position. From there, a for loop will be used to pretty much map out the unknown area. It will turn 9 degrees in place 4 times to collect the information. And for each loop, the distance information will be stored into the distance array. Once the for loop ends, we will know the unknown dimensions of the area. So we will use the if statement to determine which direction the robot should take. And then another if statement to determine which direction to take. And once the robot reaches the center of the unknown environment, we will call the red LED to turn on, and it'll stop forever until button 8 is pressed. So before that'll be the end of our loop. The next function is a turn robot function with its parameters. There's a 500 millisecond delay to allow the robot to process. Left count and right count is reset to 0. The number of pulses needed to turn in place is calculated by calculating using this function right here. After the number of pulses is calculated, we will set the motor speed to so the robot will turn. A while loop will be used to loop until the pulse count is met. Here, count left and count right are stored with the encoder counts. And an if statement is used to check the pulse count to determine if left is going faster to the right count or count left is greater than the right count, and we will adjust the speed accordingly. And once the loop ends where the number of pulses is met, the motor will stop. Below the turn robot function is the drive straight function. It's fairly similar. There's a 500 millisecond delay to allow the robot to process everything. Both variables, the count left, count right, variables are reset to 0. The number of pulses needed to drive straight is computed by calling the count for distance function. Both motor speeds are set to the speed. After that, we'll have the while loop to loop until the pulse count is met. Left count and right count are stored with the encoder counts. If statement is used to check pulse count. If left count is greater than the right count, or the left count is less than the right count, we will adjust the motor speed accordingly. And once the robot has reached its destination, the motor speed will be set to 0 for both motors. Below the drive straight function, we have the count for distance function. This function is used to determine the number of pulses needed to travel a certain distance. So here we compute the real rev per pulse. Once we have that information, we will compute the number of pulses to travel the distance. And once we have that information, we will return that information back. Same thing goes for the count for turn. This function is used to determine the number of pulses to turn in place. First, we will compute the wheel rev per pulse. Once we have that information, we will compute the number of pulses to turn in place. We will return that information. And the function below that is the get distance function. This function is determined to measure distance using the ultrasonic sensor. So here it declares as variables and the array size. For loop is used to store the measured distance in the array. Here it turns on and off the sensor when I'm using it to measure the distance. The if statement is used to filter out if the distance is in spec with the sensor. And then if it is, it will store the distance into the array. Once we have the measured distance in the array, we will sort the array in descending order. These for loop is used to sort the array. The second for loop is used to compare the values. Once we do the comparison between the values, it will sort the information in original descending order. And in that array, we will use the median to return the measured value. And that's pretty much it for my program. I will upload the program to my robot. Okay, it's ready. Go to the stage, testing environment. So here's my testing environment. We have a width of 94. 94 centimeters by 120. By 120. And then the center of the unknown area is marked off with the blue tape. So here I'll start the program by pressing button A. Here now the robot's checking for the closest distance. Okay, now it determines the closest location, so it'll rotate clockwise to its previous position. Now the robot's mapping the unknown area, so it's going to turn 90 degrees. It's going to go back to its original position. This is when it'll made its decision using the information. And that's it. Red LED light turn on, signal